for everyone who's participating right now and those who are watching the videos, as they're watching the videos, what is the one thing you want them to be thinking about? And what is the one thing they're going to take away from this talk?
Um, I would say that speed definitely matters when it comes to agents, and somebody who's using an agent does not want to see a slow agent, right? They want to get their answer as quickly as possible. People are impatient. Um, and I'm going to be sharing strategies on how you can make it faster and make it a better experience for your users.
Nice. It'll just be one slide that says use Grok. All right, let's jump in. Take it away.
All right. Hi everyone. For those of you who don't know me, I'm Aarush. I lead Evals at Groq. What this goes from anywhere. The scope of my role goes from like bringing up new models on Groq hardware to working with customers to figure out how Groq is uh, good for their specific use case. So a lot of the customers who I interact with, one of their biggest bottlenecks and one of the reasons that they turn to Groq is latency, right? When they have some sort of agent workflow, they uh, they find that when they're using OpenAI or Google or Anthropic, their agent workflow is taking like 45 seconds to a minute. Uh, and they see Groq and they see that we're fast and they're like, please, can you help us speed this up? Um, so today I want to dig into like a few like actionable strategies on uh how you can reduce the latency of your agents. And to be very honest with you, some of those ways are not going to include using Grok, right? We're not going, this isn't going to be a talk where I just show fast inference because that's not the only way you can reduce the latency of your agents. So a lot of the strategies that I'll be sharing, you'll be able to use even if you don't want to use our product. So maybe we can start with um, something about breaking down what exactly I mean by latency and what are the key metrics that you should be paying attention to um, when you're building an agent. So the first one that so we have four of them here, right? TTFT, TPS, E2E latency, and step latency. So I'm going to go down this list and I'm going to basically define each one of them. So TTFT is time to first token. A lot of you guys might know what this is. This is the delay from the moment that the user sends the request or the agent decides its next step until the very first piece of output starts rendering, right? This includes everything, which is receiving the request, building the prompt, calling the model, starting to generate. So from our testing, users start to feel frustrated around like the 500 millisecond to 1 second mark when it comes to time to first token. Unfortunately, that time to first token has sort of been normalized, right, with a lot of the larger models that are out there. But a lot of more general users seem to think that something's broken if their software isn't responding within a second or two. The second one is tokens per second. Um, so once like text starts appearing, how fast does it flow, right? So at 100 tokens per second, which sounds fast, right? A detailed like 1,000 token response still takes 10 seconds just to generate. This is after TTFT. Um, the third one is uh, end-to-end latency. This is what the users like actually experience. This is the total time from the question or the start of when you call your agent to when you get your complete answer. It's not just the sum of step latencies, which we'll get to later. But actually, let me go to step latencies first. Um, so step latency is one that you guys may not have heard of before this talk. But in its essence, step latency is how long it takes for one step of an agent to run, right? So agents work in steps. They'll observe the situation, they'll think about it, they'll decide what to do it, process the results. So each step has its own latency that can include like time for the LLM to reason, or time for it to call external tools or APIs, and to parse and integrate results. And then of course overhead from state management. Right. So going back to end-to-end latency, it's not just like the sum of step latencies because agents don't always run linearly, right? They can backtrack, retry failed operations, refine their approaches. A task that could take 30 seconds can balloon to 90 seconds when things go wrong. So maybe we can do a little demo of what exactly I mean by these metrics, right? So uh, in case you guys don't know, Groq has their we recently built a an agent system called Compound Beta, which basically integrates web search and code execution into like the actual LLM call. Uh, so you don't have to deal with like building your own agents and um, kind of uh, create all the infrastructure on like web search tools, APIs, and code execution. It's called Compound Beta and Compound Beta Mini. If you guys want to check it out, console.groq.com. There's the show, one of the only shows we'll have in this talk. And then, so I'm going to ask Compound Beta Mini, like, who is Jason Liu from 567? We're going to see how fast it runs. That was pretty quick. So in this uh, agent, this is like a very simple agent. Um, the first thing that Compound Beta Mini is going to do is it's going to figure out like what exactly it needs to do. So it's going to conduct a search. Then after that, it's going to call the search tool, get its results back. And then after that, it's going to summarize what it got from this search and return it to the user. So in total, that took around how long did this take? Yeah, like 6/10 of a second, right? Um, Now if we compare this with Perplexity Sonar, which is another like similar compound system where Perplexity integrates some form of web search into their LLM and allows you to access it by API the same way we do with Compound Beta. Still going. 2 seconds, 3 seconds. And by the time you get the full response, which is pretty similar, it's been 11.24 seconds. So I want you guys to think, what do you think is going to be like a better user experience, right? Something where the user gets the response back in less than a second, or one where it takes 11 seconds, right? Um, okay. So we've kind of illustrated how latency can compound in like real agents, but maybe let's walk through like a more complex example than just like a web search request, right? Um, so let's say you have a travel planning agent. I know that travel planning agents are kind of overused in terms of for like agent demos, but like bear with me. Um, so a travel planning agent can have multiple steps, right? And so the first step is going to be to parse the request. The agent needs to understand what you're asking for, right? That's one LLM call. That's 1 second. Step 2 to 3, you're going to search for flights. The agent calls like a flight API and then uses the LLM to parse results, right? Does the same thing for hotels. Searches for hotels near where you're looking for. Oops. Um, that's another tool call. Then it's going to filter options, which is a bunch of internal logic, maybe another LLM call or a call to a re-ranker. Um, actually, the demo here that I'm trying to show is like you're trying to book a flight to NYC from SF and book some tickets to MoMA. Right. So then it's going to find museum tickets, which is another tool call and a web action. And it's going to draft its itinerary. Then it's going to check the cost, refine and format the output. This is all like 9 steps total. And this will take like a decent amount of time. Let's say the step latency for each of these steps can go anywhere between 1 to 3 seconds. In my notes here, I have that it takes 11 seconds total, right? But that's the happy path, right? Like what really happens? Let's say the flight search returns too many results, so the agent needs to refine the search. That adds another 3 seconds. The first hotel API call fails and needs a retry. Add another 2 seconds. The agent realizes it should also check transportation options. That's another 4 seconds. So now we're at 20 seconds, and that's still optimistic, right? I've seen agents spiral into these loops where they're essentially like debugging their own queries. A 30-second task becomes like 2 minutes. A user does not want to wait 2 minutes for a response from an AI system, right? So the key insight here is that like latency doesn't just add up, it also multiplies with complexity. So each decision point, each potential retry, and each refinement step will compound the problem. So how do you fix this, right? I'm not just here to tell you guys what the problem is, but I'm also here to tell you how you can make your agents actually faster. So I have a few like optimization strategies, four in total. So the first one is faster core inference, right? You can use a faster or smaller model, uh, like Llama 3.370B instead of like GPT 4o. You can also just accelerate the model itself by quantizing it and from like FP16 to int8, or using like a hosted provider like Groq, which uses where we use our own custom silicon to accelerate the model. You can use efficient runtimes such as XLlama, SGLang, VLLM, or you can train like a model, a faster or smaller model to mimic the larger or slower one. Um, the second way that you can optimize your latency is not actually by attacking the latency at all. All you need to do is stream the intermediate steps, right? Um, Essentially, the user doesn't need the response as quickly as possible, right? Um, they just need to know that something is happening, right? So if you've seen deep research from on ChatGPT, um, you can see that when you send off like a deep research job, all that's you don't just get like a progress bar that keeps loading for a solid 30 minutes. You can also see exactly what deep research is doing, right? Like what websites it's searching for, like what its thought process is. This allows your users to understand that something is actually happening and you're not just sitting there looking at a blank screen. Um, there's another pattern that I've seen a lot of startups do. There's a concept in UX called progressive refinement, where um, the in the context of agents, this means that the agent will first stream in like a quick acknowledgement of what exactly you're trying to get it to do, then like a rough answer, and then it'll iteratively provide like better answers based off of all the data and the steps that it's going through, right? Um, for us as developers, this is great if the audience for your agent is a developer, because developers love to see the internal state of an agent. And for more general users, they see how the agent works, and they get an idea of how exactly uh, you're providing it with actionable steps. How exactly the agent is um, going through the process of solving the user's problem. So the third method is parallelism. So optimizing sort of an agent graph, right? So if we look at our travel example, once we know like the destination and the dates for where we're trying to do, why are we searching for flights and then hotels and then activities, right? These don't depend on each other. You can run them simultaneously, right? Three 2-second operations in parallel takes 2 seconds total, not six. But this requires rethinking your agent architecture. You need to map out what exactly the dependencies are. What information does each step actually need? Often this is much less than you think. So there are two types of like parallelism that I like to implement when I'm making an agent. The first one is data parallelism, which is processing multiple documents or search results simultaneously. And number two is task parallelism, which is running different types of operations at the same time, right? Um, and then the fourth optimization that I have for like when you're reducing latency is using speed improvements to make agents better, not just faster. You've made your agent faster with either core inference, streaming intermediate steps, parallelism, or any other form of like speed improvement. But you can also invest these speed gains into quality, right? If you've cut your latency for your agent from, let's say, 20 seconds to 10 seconds, you now have like 10 seconds of budget to spend. So how do you invest it, right? Um, you can give these all of these 10 seconds back to the user, and just make your agent have the same quality but make it be faster. But you can also increase the quality for the same amount of time, right? So you can do this by um, implementing other strategies for quality improvement, like best event sampling or multipath reasoning slash mixture of agents, and then more thorough like tool use. All right. Um, so wait 1 second. Sorry, I'm lagging. Sorry. Um, so best event sampling, for example, which is where you ask an LLM to uh you call an LLM with the same prompt multiple times and you ask it to pick the best one. Um, you can also do um you can also do like self-consistency, which is like having the agent solve problems multiple ways and then verifying that they agree. This catches like many failure modes, but requires 2 to 3 times the amount of inference. You can do verification loops where after the agent generates a plan, you can have it critique its own plan and then revise. Um, but yeah, so those are the four methods, right? Faster core inference, streaming intermediate steps, parallelism, and then investing your speed gains into quality. Uh, so a few key takeaways for from this talk, right? Number one is that latency compounds, right? Multi-step agents will amplify delays, understand your TTFT, tokens per second, step latency, and end-to-end latency. Number two is to measure everything. So make sure you're tracking each of these different metrics. Then you can attack latency on multiple fronts with core inference, streaming, and concurrency. And then your speed can unlock quality, right? You can reinvest time savings into better reasoning, sampling, and verification. Um, I think that's about it for what I have here. But if you have any questions, Jason,
Yeah, I have a couple
that's
questions,
about
but
it. Yeah,
let's make sure we give some folks some time to leave them in the chat. So again, there's a link. You can add your questions there, and we'll upvote them. One thing I'm actually really curious about is, I think historically with these, machine learning systems that were not LLM based, if you were
mhm,
getting latency improvements, you're always going to be better off. And I really like this perspective
yeah,
of actually just going back and reinvesting the latency gains. Um, One thing that was a big issue for the recommendation systems world was you would find that, even I'm at a project in like 2019 where we improved the latency of our system by 500 milliseconds, and it was an incremental $8 million in revenue. Do you feel like
mhm.
companies using LLMs today are able to have those kind of results yet? Like I'm curious if anyone has said, we use Groq and just through latency alone, we're making more revenue, we have more bookings because things are like working and stuff like that. I'm really curious if you've seen any kind of results like that in the wild.
Definitely. I've heard of a lot of anecdotes and I've seen a lot of
Yeah.
companies who have switched over to Grok and they've started using faster inference. They've cut down their response times and they've gotten excellent feedback from their customers who have said that, you've shaved off like the experience of your product seems so much better. And they've been able to demo these things in like existing like sales calls and things and said, hey,
Yeah.
we just cut our latency by like 50%. And
Yeah.
that provided an edge over other competitors who had the same product, but it was slower.
Mm, I see. But yeah, but it sounds like we're not at a place yet where we kind of know that, okay, if you had a, you know, uh, LLM booking agent, if it was
Mhm.
10% faster, there's actually going to be like more bookings.
Yeah, I don't think we're at that stage yet because agents are, even though they've been around for like a few
Like,
years, they're still quite nascent, right?
yeah.
Not enough people or companies know how to
Yeah.
build them in such a way.
Makes sense. Makes sense. I've seen some like anecdotes from our end, but yeah, I don't think we've ever seen any kind of real research yet on like how latency affects the bottom line. But figured out what to ask. Figured out what to ask.
Yeah.
Um, yeah, let's jump into some questions. in terms of the people you're working with, like what are your favorite tools to measure things like latency and how do you embed them into your workflows? Is it Datadog? Is it, Logfire? Is it like Brain Trust? What have folks been using recently?
I think we interact with a lot of startups who are closer to, you
Mm,
know, like what the cutting edge is. And I think brain trust has been the tool of choice for
mhm,
a lot of companies when it comes to like evals and instrumentation around like measuring latency and things.
mhm.
We've also seen a lot of cases of like larger companies rolling their own like instrumentation
Yeah,
stacks for this. Again, it comes back to the point where it's like the the industry is very much still in its early stages, and people don't know what the best thing to use for something like this is.
makes sense. Yeah, I guess what kind of workflows have you seen around the latency work? I think, for most of
Mhm.
what I've done in the past, it's just been we track everything in Datadog. We had these group buys. We sort of just tackle things as they come. But do you feel like
Mhm.
there's any difference in trying to optimize these LLM apps versus these traditional applications?
I feel like with traditional applications, it's much more deterministic what each step is and what the latency of each step is.
Hmm.
Um, and you can provide like proper alerting about, let's say, um, I don't know, this API is taking 5 seconds instead of the 500 milliseconds that it's supposed to take. But with LLMs, it's much harder to kind of figure out like how long exactly an LLM call is going to take, or how many steps this is going to take. So I think it's not as much like alerting, but more just logging and having like robust dashboards for how long each step is taking, or how long
Hmm.
like your overall agent workflow is taking, and trying to go just monitoring that and figuring out um like where the bottlenecks
Yeah.
are a little more intelligently. Like a lot more thought needs to be put into how latency is tracked, and it's still very much like an early stage.
Yeah, makes sense. I think, even this idea that you can turn on this reasoning and you now have to figure out like what is the budget I have for both performance cost because it costs more tokens and the latency of these systems because they
Yep.
take a little bit longer. Um, have you noticed any specific domains that are more or less sensitive to these kind of latency things? Like the example I always give is like e-commerce when you're trying to sell something. Um, but I'm curious what you've seen elsewhere.
I think definitely more in the consumer space, like e-commerce, chat apps, or like, customer support is like a huge thing
Hmm.
that
Hmm. Yeah.
people are going to customer support because they're annoyed, right? They don't want to wait even longer for a response.
Yeah.
Um, what else? Um, I think just generally like latency is something that doesn't hurt to have, and like latency in any way kind of pisses people off.
Hmm.
So having less
Yeah.
of it is just generally a good idea.
That's oh, this is a good question. Can you give an example of what you mean by data parallelism versus task parallelism?
Yeah. So for data parallelism, let's say you have like 20 documents, right? And you want to you need to process them in some way. I feel like data parallelism is like a subset of task parallelism, which is very um determinant on what you're working with.
Mhm.
How do I explain this?
Maybe it's a good opportunity to have a
Yeah,
data parallelism blog post for the
maybe it
Groq
is.
page.
Yeah.
Yeah, yeah. We
Um,
can follow up on that if you'd like.
well, yes, let's do that.
Awesome. Let's look at some other questions before we jump into some of the live questions. Oh, this is a good one. How do you think about things like caching mechanisms? I have my own answer, but I'm curious to hear your thoughts.
I think caching is definitely a method that I should have covered in this talk that I didn't. But yeah, a lot of providers like there's prefix caching and then there's like actual like LLM prompt caching that you
Mhm.
can do on your end. I think prefix caching is immensely useful. So you should be structuring your prompts and like your agent workflows in a way that an API provider can have more cache hits than cache misses, which means like trying to keep as much of like the large context at the top of like your prompts, and then um, any changes that you make, like additional uh, data or things, should come after like your after like previous chat turns. You can also use things like light LLM to like actually cache identical prompts so that you don't even have to call the LLM provider. That can be incredibly useful for saving LLM costs and latency.
Mm,
What are
nice.
your thoughts on it?
Um, I mean, I think a lot of it could be also around like one of the things I like to do is doing almost like caching chains of thought.
Hmm.
And so, maybe in the first time you run this tool, you might have to, so not chains of thought, the answers to questions, right? So, for example,
Hmm.
um, maybe the first time I ask a question, I have to retrieve 10 documents, generate an answer.
Hmm.
And if I have some user feedback that says this is a good answer, next time that answer is part of the context. And the idea is that like instead of actually doing all this reasoning to get the answers, like by the way, here are the 10 pieces of context, here's like three baked answers. You don't
Hmm.
have to reason as much to get the original answer. You just sort of like repeat yourself. That could be one way of doing it. Or building a UI that says, let me just render those three answers first and then start streaming out tokens. And so the idea is that the latency here is, I can have some classical code paths that render answers that sort of reduce the time to first token to zero. And so at least I'm seeing
Yeah,
something on the page before I generate a new answer, right? It's almost like showing the links first and then showing the token streams out.
that checks out.
Um, so let's also do some live questions. So if folks can see the React, you can sort of raise your hand, and we'll call out some questions that way. And then as people are sort of figuring out the hand raise mechanism, I'll go over a couple more questions. Um, this one is also really good. I have some thoughts here, but how far are we from having systems that are so fast and cheap that charging per token won't make sense anymore?
I think
I guess it's different because your Grok will probably likely remain in that world for a little bit longer. But yeah, I'm curious.
I think it's going to be a while until that happens because the cheaper and cheaper that the tokens get and the faster and faster that the tokens get, the more you're going to throw at every single agent
Yeah.
or problem. Um, but I do think that the cost is going to go down to close to negligible levels within 2 to 3 years. But it also depends on like very hardware specific things because
Yeah.
that's like the hardware iteration speed is kind of like the bottleneck here. Um, the chips need to be efficient enough for it to be
Yeah.
for like the costs to go down. That's what we're working on with like our V2 chip. Trying to just increase the throughput so much that cost just hits the floor.
Yeah. I think the other thing to call out, really two things, is once these costs go down to zero, again, you can kind of reinvest the latency and reinvest a budget to just say, well, I want to generate like 10 answers and take the mean or something like that.
Exactly.
I think the thing that might not be on the inference businesses, but on the application layer, is I've seen a lot of companies now price on success. So, for
Mhm.
example, Sierra, they use chatbots to do customer service, and what they do is they don't charge you whether or not the conversation is long or short. They charge you when the ticket is closed, and I think Sierra says like, well, we take $1 every time we answer one support ticket, and it is closed, and the customer is happy. Um, and that's actually really exciting because what it means is if they do get all these savings, they don't make less money because they're not like going any faster. And so they use a company like Groq. You can say, you know what, we're going to do way more complex things because all I'm trying to do is close this ticket to get that return. And how much things cost in the interim, those are things that we can optimize for. And so I think once companies start thinking about pricing on outcome, pricing for the results of the work done rather than the work itself, I think it's going to be sort of like another explosion of what is possible in terms of the businesses that we people operate. I think we're getting pretty close now. Like if I just do like multi-agent, like simulations, and they're twice as cheap, I'll just do 4 times more because my goal is to get that dollar to close that ticket. And as long as it's affordable, it's affordable. Yeah. Uh, Manoj, do you want to ask a question?
Yeah, for sure. First of all, thanks, guys. Great content. Learned a lot. I just had a question on all these evals that we're talking about are very quantifiable. But take the trip planner example. What about the subjective criteria, and how do you eval that in agentic systems, right? Like, so how good is the trip planner? What are the evals that you would use for that when there are multiple steps? And then related to that, you could have something where you optimize for local steps, but the global might change. You know what I mean by that is the flight might come in much later, or like the hotel booking might be, you might miss the museum trip because your flight is coming too late, uh, because you're optimizing each for some, like, so there's subjective criteria and also quantitative criteria that might not uh, meet the goal of what you do normally. So I was just wondering, how do you evaluate subjective criteria and then local versus maximum in agentic systems?
I
Does
think
that make
it, yeah, that makes a lot of sense. I think the most important thing is you need to you need to look at it on every layer of the stack, right? So first of all, uh, you can get like direct user feedback on your agent and whether it's actually performing the way that you'd like it to. The way if you've seen in like ChatGPT, they have like the thumbs up and thumbs down button. That's uh that's the way you can do it. But when you're looking at um
pre-production?
yeah, sorry.
I was talking more about before it goes out live,
Uh-huh.
maybe you do an alpha program or whatever, but
Mhm.
I was just trying to figure out what are the best practices you've seen, especially with subjective criteria.
Mhm.
Let's look at the
Yeah.
the the
I'm
quantifiable.
happy to chime in as well afterwards.
Sorry.
I'm happy to chime in afterwards as well. I
Yeah.
have some thoughts on.
I think first of all, you're going to need to figure out what model is specific, like best for like the specific use cases, like the specific steps within the agent, so that you can um so for that you'd probably try to build your own evals for first of all what the trip planner's like original goal is, and then uh what the goal is for each step. Like maybe a specific bespoke eval for like finding the best flights given a specific piece of data. Um, and then yeah, honestly, it's very much just building subjective, very bespoke evals for your specific use case. Um, I think Jason would be able to explain this a little better than I am. But
Yeah. I think the real call out here is that you just can't do that much pre-production. Like you can, there have been companies where they will do simulations where they'll say, you know what, we're gonna make like 45 different personas, or we're gonna have a writer come in and set up all these sort of hypothetical situations and then run evals on that. But ultimately, you at some level, what you need to release is you need to release a simpler version of that product and start getting real traffic. Because the long tail of failure modes are things that are very hard to predict. So that's one thing. Um, Once you do that, then once you start enumerating these failure modes, what you end up doing in practice, you either sort of write some kind of LLM as a judge. You sort of make sure that they are aligned with human preferences on whether the quality is good or bad. So, for example, given a conversation history that happened, can I predict the user frustration, or how often has the user requested different results? How often has the LLM called the tool incorrectly? And you can basically do this process of taking the conversation, extracting structured data out of those conversations, and then doing the data analysis. And it's often going to be the case where you kind of have these plots of, are conversations that are very long, do they result in more revenue or less revenue? Is the number of turns predictive of like customer satisfaction? How often are we predicting frustration or assistant errors? And really what we try to do is we try to sort of suppress that curve as much as possible But that's usually generally how things have worked in practice. It's hard to sort of enumerate these failure modes all ahead of time, just because people tend to be really weird when talking to these systems and testing the limits of what these systems can do. Did
This
you
is
have a
great.
follow-up?
One quick follow-up. Is there any
Yeah.
resource for best practices for subjective criteria, or is there a website that, if people contribute? Because, these are like the things you mentioned out here, it takes a long time to figure these things
Yeah.
out. And I was just wondering if there's a resource that you guys have come across, or if there's a site where these are kind of cataloged that might be useful
Yeah.
for inspiration, if nothing else.
A lot of it has been tried. I try to document as much as I can in like my own blog and in some of the cohort stuff that I do, but a lot of it has been kind of walked away because they're so specific, right?
Mhm.
Um, because if you work for a consumer application, you kind of want to optimize for time spent, right? Like one of the things I'm working on with this like call voice AI is like actually turns out voice AI they're really good at doing upsells and like so we should start like building out like upsell workflows. Well, a lot of this comes down to the fact that my goal is to release a product as quickly as possible, do data analysis over the conversations that are happening, and then prioritize what's going on, right? Like we talked about this issue where like, car bookings could be cheaper if the flight arrives. Well, really what I would do is I would do my data analysis in the call history and go, well, this is a 5% problem. Right now, we should just add some prompts that say like, we don't handle this case. But if it turns out it's a 70% problem, maybe the solution is actually just changing the set of tools that we use, right? Maybe we have a single endpoint that returns flight details and call bookings at the same time, and then we can like solve some parts of that system in code. But a lot of it is around prioritization as the research and the product develops, and then we can kind of like make decisions post hoc. It's really, really hard to predict these things ahead of time. Yeah,
Thank you.
no worries. Mate? I think it's Mate. We'll see.
Mate, yeah,
Matt.
sorry.
I
Mate, yes.
Matt.
Uh,
I was like,
so
oh my
my
God,
question
2 out
is,
of 3.
no, no worries. Actually, yeah. So my question is around, like, I guess most people use um, larger LLMs for most of the tasks. Uh, I've read maybe last year more about these surrogate where you would use a large model to train a small model. Some of these tasks might be more like maybe you're using an LLM for parsing parameters from an API or whatever, and you could actually use like a text classifier or even a like. Would you go into that level of trying to optimize latency? And then sometimes because maybe you can get away with like, I don't know, fine tuning a BERT or just
Yeah.
a smaller model for a narrow use case. Is that still a thing worth looking into or not?
I think it
Do you mind if I
definitely
take this on?
is.
Yeah.
Oh, go for it.
I definitely have some thoughts on this because I think a lot of the consulting work I've done is sort of around this. A team comes up to me and says, which model should we use? Or should we use this embedding model or that embedding model? And ultimately, it's going to be the case that we're not really optimizing for latency, right? We're optimizing for some higher level business objective and we have a budget, right? And like, the real question is, how do we like spend this budget? And latency is one way of doing it. But if we trained our own model, now we're thinking, well, now we have to invest like our time building out these new models. Maybe when will the next model come out? Is that going to be an issue? Like if we can't host these models on a inference server, do we now own all of the inference? Right? Do we now have to like hire someone who's like fighting CUDA errors and reading the VLLM docs and understanding how to like optimize GPU utilization? Um, and if we do train this model, what performance improvement is worth this other investment? Because if you did SFT and your model is 4% better, I might tell you maybe this is not worth it because you're going to dedicate a whole engineer to fine tuning and doing inference. But I think if we wait 3 months, the next model is going to come out. It's going to be a lot better. So I really think about it in terms of having this portfolio of budget to allocate. And it's really going to be a question of not just, is it worth making it faster, but is the performance improvement worth the latency improvement, worth the maintenance costs, worth the inference costs and stuff like that. And so that's kind of like how I try to think about that kind of question. But There have been
Yeah,
times where we fine tune embedding models and we get 20% improvement. It's like, oh my God, we have to do this.
It's also like a
and
question of iterative improvement, right? As long as you're able to ship an MVP, you can always work on optimizations like on each layer later on. So it doesn't have to be like a one and done sort of thing.
yeah, maybe just a quick follow-up on that. Like,
Mhm.
I totally take that point on, like, if your goal is to develop an app and that's where you spend your time, but then
Yeah.
if you're developing a platform where you want like other people to develop their RAG apps, then like, and everyone is using the biggest model for each of their tasks, there it can be actually potentially a big save, because like what I see many times,
Mhm.
at least agents in a company, is like everyone is calling the biggest one for everything.
Yeah.
And then they do get like, 30-second, so at pretty long latencies, and it is a problem.
Yeah. Yeah. Yeah, I think if you're building a platform, I'd be curious, like, what are the actual KPIs, right? Are we worried that people are going to turn off the platform? Is it the case that, they're paying $20 a month and it's costing us $16 in API costs, and maybe I want to improve margin? Um, yeah, I can imagine there's a lot of different knobs to tune there.
Yeah, thanks.
Yeah.
Gentlemen,
I really like.
Jason, just a sec. Aarush, will you please put the latency slides back up for
Yeah.
just a few minutes? Thanks.
I think someone. Yeah. This is a great question because I think about this all the time. Have your evals changed in interesting ways beyond being able to do more evals because Groq is so much faster?
Absolutely. Like Grok's systems can just handle, it can just like churn through so many tokens so quickly, and having basically unrestricted access to just screwing around with them has been like I've been able to like iterate on my evals so much more quickly when I can run an entire MMLU run, which is like 14,000 questions in like 30 seconds. So yeah, I've been able to like stretch like the sort of evals that I run and the sort of evals that I build a lot, just based off of fast inference, because the iteration speed is also just so much higher for things like this.
Yeah. I think they also benefit in terms of sort of getting any kind of statistical power. I think if I was to run my evals using 3.0 and with a lazy plus O3 with a lazy prompt, maybe I can only test 100 things. And so the visualization I can make is that it has very wide error bars. And it's like, well, I can't get it to 1,000 things because one, it's going to cost me $800 every time I run this, and every time I run this, it's going to take 40 minutes, right?
Yeah.
And so I don't feel good about changing 3 things in a prompt or changing 2 things in a system and then rerunning these things. It's going to cost me too much time. But with Groq, it is the case. Well, now I can just test 5,000 things, and I have really good confidence whether or not things are improving. I feel really good about making smaller changes and having things run very quickly. I think it has really changed the way we do and think about experimentation and experimentation velocity.
Yeah, definitely.
Enough?
Like an oh,
Oh, sorry.
eval run.
No, please finish, Aarush.
Yep. An eval run on like OpenAI's O1 like can cost like thousands of dollars, and on like let's say Llama 4 Maverick on Grok, it can cost like $2. It's like a huge difference in being able to iterate on your own product and on your own evals, cost and latency wise.
Yeah.
I feel the follow-up to that one, are there interesting user experiences that you are seeing? Like, what's the most interesting user experience beyond just like getting a response within 6/10 of a second? Just simply because you can do so much more within the budget, just like Jason described. Like, I have a second, I can do so many things. What's the most interesting user experience, maybe qualitatively different, that you've seen compared to what regular or bigger models can do?
I think a big one is real-time intelligent copilots. So I'm sure if you've seen things like Meta's Ray-Ban glasses, where they have that thing where you can say like, "Hey Meta," and you can ask it about what's going on around you. A big issue that they have is that they try to run a lot of their stuff on device, and that leads to like basically terrible quality when it comes to actually answering questions. And if they have to answer like a more like detailed or in-depth question, like they're looking at a screen and they're like, what does this chart mean? they have to call out to an API, let's say something like Meta's internal Llama API, and it'll take like a few seconds for the user to get their response back. But when you're using something like Groq, you can the user can get a response back within like half a second, and that allows them to just have a much better user experience, and you can have like real-time updating things that like every time a user is in front of like if you have like a heads-up display, you can have like a live update of like what's happening around you or behind you by just like continuously polling Groq's API and like with data around from cameras and like what's happening around you.
I'll also add one thing that I'm really excited about is if like code assistants can run on something as fast as Groq, primarily because I think at some point the inference to update your code might be as fast as sort of the website building or the app recompiling. And I think that's going to also like dramatically change the ergonomics of building applications, right? Like I would love a world where I just have like a website. It's like voice, it captures the voice, and I just say, okay, like move that a little bit to the left, and it'll just like move because the code has been edited. I have like RSI, so I can't code that much. So I think those experiences are really exciting. Where, yeah, I think a lot of it is the real time conversations.
100%.
George?
Yeah, this might be more of a question for you, Jason, but latency obviously is potentially an important metric, as we talked about for certain use
Yeah.
cases. Right now, developers are probably willing to wait a little bit longer, especially since
Yeah.
you have ways of launching multiple agentic
Yep.
flows at once and stuff like that. But I'm wondering, yeah, for those cases more out to consumers, there's obviously other metrics, evals
Yeah.
that potentially come before. I guess in your experience, when has latency come sort of in the eval, be folded in as part of your eval tool set? Like when does that come into play
Yeah.
realistically?
I don't really think of it in terms. I feel like evals are now like overloaded, right? Like usually how I think about these production systems is I have a bunch of plots and visualizations, and there's a certain shape of the curve I want to have, right? So the question is, does the time spent on this application result in more churn or less churn? Right? Is it the case that like if these conversations take longer, like people are more dissatisfied, right? If that's the case, then latency is really important, but maybe it's okay. Right. The other thing is like how much time do people spend per session? Is it the case that people are getting used to kicking jobs off, or am I like staring at the screen? Right. Like Devin, the way that we perceive latency in Devin is very different than the way that we perceive latency in Cloud Code versus even in Cursor, right? And so there's a lot of like product aspects at play. And so I usually think about like is it affecting churn? Is it affecting time spent? Is time spent predictive of revenue? Maybe that's like too business focused, but that's generally how I think about these kind of things. And really what I'm looking at are not like evals where I have like conversations that are passing and failing. I'm kind of looking at like, session time versus like churn rates. Are people who are taking too long just like more unhappy, or are they even happier? Like that. Those are the things that really, really matter to me. Especially in this cases where agents are doing things like sales, latency really, really, really matters. Right. But if it was like a call transcript follow-up, maybe it doesn't matter as much. But a lot of like booking systems, for example, like I'm used to having someone take an afternoon to book like an entire trip. So maybe it's okay that maybe the AI takes 30 seconds. But there's a sweet spot per application for every kind of consumer app.
Yeah, so it sounds like it's important for like PMs to potentially define that metric and measure that over time in production.
Yeah. Yeah, and its effect on other more important metrics, right? These are kind of
Exactly.
all
Yeah.
inputs to predict like satisfaction, churn, revenue. Sometimes it doesn't matter, right? Cool. So I think we have 4 minutes, which is pretty solid. We have another talk coming up in in maybe 10 minutes from now, and so I will make sure we get everyone some time to take a break, get some water, go to the bathroom. And yeah, I mean, thank you, Aarush. I feel like one of the big things I'm taking away is really thinking about this, like how do we reinvest that latency back in the system? That's been a pretty good insight. I'll probably bring that back to everyone else in the cohort. But yeah, I guess before we go, Aarush, is there a question you wish we asked?
I think most of the questions were actually quite good, but yeah, I think honestly, you guys asked like a lot of great questions, and thank you, Jason, so
Lovely.
much for like setting this up and being a great co-host. So, thank you so much.
Thank you. Appreciate your time. I hope I'll see you in Palo Alto.
All right.
Awesome. Take care, everyone. We'll be back in like 10 minutes. Bye.
Peace.